half a century, the reach of human exploration has ended just a few hundred miles above the Earth's surface. We have built permanent stations and flown reusable shuttles, but we have remained strictly tethered to our planet's immediate orbit. The last time any human pushed beyond this threshold was in December 1972, when the Apollo 17 crew began their return from the lunar surface. Since that mission, no person has traveled further than roughly 400 miles from the ground. We transitioned from the deep space pushes of the 60s and 70s to a long-term focus on sustaining life in low Earth orbit. Returning to the moon requires more than a simple launch. It requires accelerating a 6 million-pound vehicle to more than 17,000 miles per hour just to reach a stable starting point. On April 1, 2026, at 6:35 p.m., the Space Launch System ignited 8.8 million pounds of thrust at the Kennedy Space Center. This rocket stands 322 feet tall, taller than the Statue of Liberty, and is designed to deliver 27 metric tons of payload directly toward the moon. Inside the capsule at the top of the stack are Commander Reed Wiseman, pilot Victor Grover, and mission specialists Christina Koch and Jeremy Hansen. The rocket successfully cleared the atmosphere and reached space, but the Orion capsule is not yet heading for the moon. It is currently circling the Earth. Before mission control clears them to leave Earth's vicinity, the crew must spend 24 hours running a manual checklist of every critical life support system. The capsule, named Integrity, is currently in a highly elliptical orbit, stretching out 40,000 nautical miles. This orbit serves as the ultimate checkout phase. For the next 24 hours, the crew is stress testing Orion's survival hardware, verifying systems previously only tested by mannequins. They are monitoring the carbon dioxide scrubbers to ensure they can maintain breathable air, and checking the thermal systems to see if the capsule can regulate temperature in the extreme environment of deep space. The checkouts are detailed and unglamorous. Currently, Mission Control is troubleshooting a blinking fault light on the capsule's waste collection system, a critical component for a 10-day mission. This window is the last chance to turn back. If a major failure occurs now, the crew can abort orbit and re-enter the atmosphere. But once they leave this path, they are committed to the full journey. Beyond life support, the crew is also performing a crucial human-in-the-loop flight test called the Proximity Operations Demonstration. During this phase, pilot Victor Glover takes manual control of the spacecraft's thrusters, flying the Orion by hand for nearly an hour. After separating from the rocket's upper stage, Glover maneuvers Integrity back toward the discarded hardware, using it as a reference point to test the ship's handling and sensor accuracy. This test is required for future missions. While Artemis II is a flyby, Artemis III and IV require the crew to dock with lunar landing vehicles while in orbit. By proving they can manually pilot the ship in close proximity to another object, the crew is verifying the maneuvers needed to eventually land on the moon. Once all systems are verified, the mission reaches its most energy-intensive milestone, the Trans-Lunar Injection burn. The European service module will fire its main engine, accelerating the spacecraft to approximately 24,500 miles per hour, just enough velocity to break Earth's gravitational dominance. This schematic shows the free return trajectory. The combined gravity of Earth and the Moon naturally pulls the spacecraft around the lunar far side and back home. This path takes the crew roughly 4,600 miles beyond the Moon, exceeding the distance record set by Apollo 13. Because of the mission's timing, the trajectory takes the capsule directly into the Moon's shadow, allowing the crew to witness a total solar eclipse from deep space. The Trans-Lunar Injection burn uses raw propulsion to place the ship on a path dictated entirely by gravitational physics. During the Apollo era, the goal was to reach the surface, leave a footprint, and return. Artemis is designed for a longer timeline. This mission is the certification flight for the entire Artemis architecture, the capsule, the rocket, and life support systems that must function for weeks. Successfully verifying these systems today is required for the landings planned for Artemis III and IV. The data gathered from this 10-day flight will inform the design of the vehicles that will eventually carry humans to Mars. Testing these systems in Earth orbit confirms the hardware is ready for the deep space transit. It marks the first time in 50 years that humanity has successfully cleared this phase of the journey.
Thank you for watching.